So you can write them down or not. You can just look at your sheet if you want to. All right. So we have a double angle formula for sine, cosine, and tangent. And so the first thing we're going to do is solve an equation by using the formula. So we're going to call this section 7.3, day 1. And these are the double angle formulas. All right, so we're going to revisit solving equations. So if it's something that you're still really struggling on, maybe today will be the day it all starts making sense. So for example 1, we're going to solve in the interval from 0 to 2 pi. All right, so we're going to give all the answers that are the angles in that interval that work for the equation. And our first equation is the sine of 2x minus cosine of x is equal to 0. Now, today is the lesson on double angle formulas. So it's kind of obvious that we're going to use a double angle formula to do this. But I need you guys eventually to see this question like 10 days from now and just be like, okay, I need to use a double angles formula. So we can't solve it another way. Like we can't isolate the sine or cosine because we have 2 of them. We can't isolate both of them. And then the other thing we can't do right now is factor it because there's no common factor. It's not like a trinomial or anything. So hopefully when you see that, there's really no options except to rewrite sine of 2x as 2 sine of x cosine of x. All right, and then from there, we're going to solve it just like we've been doing. I feel like we've been solving equations for a long time. So what would you guys do? Factor out a common factor. And that common factor is going to be cosine of x. So I'm factoring out of what's in front of the minus sign first. So that cosine of x just cancels out and we're left with 2 sine of x. And then what do you get when you factor it out of itself? 1. Good. All right, and then I didn't say this, but every time you're solving by factoring, it has to equal 0. There was a lot of people that on the last quiz we took, like it was 1, and they moved the 1 over, and then they factored it and set everything equal to 1. That doesn't work for 1. The reason we can set each of these equal to 0 is because with multiplication, the only way to get 0 is to multiply by 0. So if you multiply those and get 0, it means one of them is 0. That doesn't work for any other number. Like if it equaled 1 and you set them both equal to 1, that doesn't work. I mean, 1 times 1 is 1, but so is 2 times 1/2 and 3 times 1/3. So it has to be 0 if you're factoring, or otherwise it's not going to work. All right, so now we want to solve each one of these. So this one is already isolated. This one I have a couple of things to do. All right. Now I have erased the hand trick off the board, but hopefully you guys have it in your brain. But this one on the left, what are we going to use? The cosine is 0. The unit circle. So you can draw it if you want to. If you just have it in your brain, that's fine too. right, and if we're going to find the cosine of an angle from the unit circle, what do we use? The x-coordinate. So we want the x-coordinate to be 0. And so that happens here and there. So we get 2 angles from the unit circle. Okay. And then over here, for the sine to equal 1/2, if you are doing the hand trick, then that means we want 1 bottom finger. All right, and so that's going to be pi over 6. Right, and then this is the sine is equal to a positive. So where is sine positive? So I want pi over 6 in quadrant 1, and I want pi over 6 in quadrant 2. And that is it. Those are the 4 angles we can put into that equation and have it work out. All right, so hopefully that feels familiar to you. We've done a lot of those. All right, the rest of it is going to be pretty new. So the next one, for example 2, we're going to use a double angle formula to rewrite. We're going to do a couple of these. So the first one, we have the quantity cosine of x plus sine of x times the quantity cosine of x minus sine of x. So if you're looking at your double angle formula, does that look like any of them? Not really, but if we multiplied it out, it might. So because these are the same terms, just the different sign, I can do shortcut multiplication. And then Ty was right. That matches up exactly with what cosine of 2x is. Right. Let's look at one more and then we'll do something a little different. So for B, we have 8 sine of x cosine of x. So if you're looking at the double angle identities, it looks the most like this one. But to do this one, it actually does need to be a 2 right there. So any ideas? Can we write that with a 2 right there? Take out 4, right? So we can rewrite 8 sine of x cosine of x as 4 times 2 sine of x cosine of x, which is going to be 4 sine of 2x. Okay, so to use the sine of 2x formula, we actually need 2 sine of 2x, right? So I knew that to get 8 is 4 times 2. And then once you get that by itself, you can just change it. Right. So on that challenge exam, they're not going to tell you what identity or which formula to use. You're going to have to make that decision for yourself. So you might see something like this one where the directions are just find the exact value. And we have 2 sine of 22.5 degrees, cosine of 22.5 degrees. So if you're looking at that and you're like, how do you find the sine of 22.5 degrees? You can't. You don't know how to do that without a calculator. You can't. But hopefully you're gonna, when you see a trig, you're gonna look at your identity sheet and you're gonna see that it looks like this. What's t in this case? 22.5. So you can rewrite that as sine of 2 times 22.5. Degrees. So what is 2 times 22.5 degrees? 45 degrees. 45 degrees is special. It's actually super, it's not there anymore. It's super special because it's actually a finger on your hand trick. So it's going to correlate to the middle finger. And so what is the sine of 45 degrees? Square root of 2 over 2. So it's the square root of the bottom fingers over 2. All right, any questions on that? It's less obvious. Like I said, on Friday, we're going to really focus on picking out the right formula to use. Okay, now the last example we're going to do, I took up the whole page, but I write really big because I write on unlined paper. But if you're at the very bottom, you probably want to go on the back to do this problem. It's kind of like 3 problems in one. So for example 4, we're given that the cotangent of u is equal to -6. And pi over 2 is less than u is less than pi. So what we're going to do is find the sine of 2u, the cosine of 2u, and the tangent of 2u. And yes, this is a double angles formula day, but hopefully if this was on another day, like a quiz or a test, you would see the 2 u's and just focus on the double angle formulas. All right, so let's start off and just figure some things out about u. So what quadrant is u in? Second quadrant. So anytime the angle is between pi over 2 and pi, I guess let's look at pi over 2 and pi, that's the second quadrant. So let's draw the second quadrant. Ooh. All right, this is going to be u. And to use these double angle formulas, we need the sine, cosine, and tangent of u. Do we already know the tangent of u? It's the reciprocal of the cotangent, so it's -1/6. All right, so what does that tell you about a couple of the sides? Very good. Now, yesterday, I think all of our triangles were just perfect little Pythagorean triples. This one, we're going to have a radical, but that's okay. So to figure out the hypotenuse, we're just going to use the Pythagorean theorem. All right, then we'll go back to our triangle and find the sine and cosine of u. And I'm actually going to leave these radicals in the denominator. You don't have to, but it definitely is going to make it easier if you do. Now, if you forget and simplify the radicals, it'll still work out. It'll just be harder. It'll just be harder for you to do in your head if you don't do it this way. All right, so we have everything we need from u. Now, I did make the cosine negative because it was in quadrant 2. So now I'm going to go back and find all the things. So we're going to start with the sine of 2u. I'm just going to write out the formula. And then we already figured out what the sine of u and the cosine of u are, so I'm just going to fill those in. Right. And then I'm just going to multiply these fractions together. So you can put this 2 over 1 if you want to, if you need to, but we're just going to multiply across the numerator and across the denominator. And that's it. That is the sine of 2u. So it kind of worked out that we left it as a square root, because when we multiply square root of 37 times square root of 37, it's just regular 37. If we had simplified that radical, we would have to know what 37 times 37 actually is, and then reduce the fraction. All right, any questions on that one? Okay, a couple more. Let's do the cosine of 2u. So I'm just going to write down the formula. Then I'm going to put in what the cosine of u and sine of u are, and then square that, and then subtract. Okay, so we square the numerator and the denominator on both of these. Well, some people in my earlier class, when we did the sine of 2u and got a negative, they thought we messed up, because u is in quadrant 2. Does that mean that 2u is in quadrant 2? Double u? It definitely isn't. So an angle in quadrant 2, like if it was 120, that the double of that is 240. It's in quadrant 3. But if it was an angle like 150, double that is 300. It's in quadrant 4. What quadrant do you guys think this one's in? 3 or 4? This one's in 4, because the sine's negative and the cosine's positive. So it's an angle like 150 degrees. All right, one more. We need to do the tangent. Now, I am actually not going to use the double angle formula to do the tangent. We could. It will work out, but it's a little easier if we use a different identity. If we use a reciprocal identity. So if we want to use, or actually, not reciprocal, quotient identity. So if I want to use a quotient identity to figure out tangent of 2u, what would I do? What would I divide? Sine of 2u divided by cosine of 2u.
Would you do that every time, or just?
For me, if you have the sine and the cosine, then I think it's easier to do this, because you are going to have fractions, but the other ones you're still going to have fractions. This is definitely easier. No, but if it was just asking you to find the tangent of 2u, probably just do the formula for tangent. All right, so we have sine of 2u was negative 12 over 37. Cosine of 2u is 35 over 37. And then how do you divide by a fraction? Multiply by the reciprocal. All right, that's going to cancel. The tangent of 2u is negative 12/35. So that's all three. All right, so what questions do you guys have about double angle formula?
It's easier than the last 2 days. So.
All right. Yeah, it is. And maybe you're getting a little better at formulas. I don't know. Okay. Your assignment is a worksheet.